In this presentation, we will learn how to insert a new node at the beginning of the circular doubly linked list. So let's get started. Let us suppose this is the initial state of the circular doubly linked list and tail pointer is pointing to this particular node. Our target is to insert this new node at the beginning of this particular list. We are having just one node in the list and we want to insert this new node at the beginning of this node. Okay. Here you can see there is some pointer new p pointing to this node as well. Obviously there must be some pointer pointing to the node, right? For this purpose we need these 4 lines of code. New p next equal to tail, new p prev equal to tail, tail prev equal to new p, tail next equal to new p. Okay, this is the prev part of the node and this is the next part of the node. You should always remember that, right? Here these 4 lines of code are required in order to add this node at the beginning of this node. Let's just try to understand this piece of code. First, let's see this line, new p next equal to tail. That means we should update the next part of this node so that it can point to this node. That is, we will store 1000 address over here. After this, new p prev equal to tail is written, which means that we will update the prev part of this node so that it can point to this node. Again, we should store this address 1000 over here. After this, the prev part of this node must be updated so that it can point to this node. That means we must store this address 2000. We know the address of this node is 2000. After this, we will update the next part of this node so that it can point to this node. Again, we must store this address 2000 over here. The resultant linked list so obtained looks like this. We have successfully added this node at the beginning of this node, right? And tail pointer is still pointing to this node. Now, let us suppose we want to add one more node at the beginning of the above list. And this is the new node we want to add at the beginning of this node. For this purpose, we want the address of the first node, right? In the previous case, we just have one node in the list. And that is the first node of the list as well as the last node of the list. But here in this case, we have 2 nodes. We need the address of the first node. For this purpose, we will keep a temp pointer and it must point to the first node of this list. That is why I am putting this line struct node start temp equal to tail next. So there must be a temp pointer which must point to the first node of this list so that we can use this for the purpose of adding this node at the beginning of this list. Now here we should change this code by this code. So we have to change this code. Here this tail must be replaced by temp and this tail also must be replaced by temp and the rest of the code will remain same. You can see over here that first the next part of this node must be updated so that it can point to the first node. Right, because this is going to be the first node of the list, so it must point to this node. And the prev part of this node must point to the last node of the list because this is a circular doubly linked list, right? After this, the prev part of this node must be updated so that it can point to this node. And the next part of this node must be updated, that is the last node must be updated so that it can point to this node, right? This is all what we need. So here, this piece of code is used for inserting the node at the beginning of the list, even if there is just one node in the list. There is no need for creating a separate code for adding the node at the beginning of the list when there is just one node in the list. We can use this code for adding a node at the beginning of the list if there is just one node in the list. And the time complexity of this piece of code is obviously constant, right? That is big O of 1. So it is clear from this fact that adding a node at the beginning of the doubly linked list takes constant time, right? Now let me just execute this code in code blocks. So here is the complete code. We have a struct node and you can see over here inside the struct node we have a prev part, the data as well as the next part, right? After this we have this add to empty function. And we know that this function will help us in creating the first node of the list, right? After this, we have add at beg function, and to this add at beg function, we are passing tail pointer as well as the data, right? Here we have a new p pointer which must point to the new node. For the creation of the new node, we are calling add to empty function, and to this we are passing just the data. After this, we are checking this condition. If tail is equal to null, that means if we have no node in the list, then we should return new p. That means the newly created node becomes the first node of the list and that is the only node. That's why we should return new p. Else, we will create one temp pointer and this must point to the first node of the list and then we will evaluate these 4 lines of code which we have already seen and finally we will return tail back to the main function. And here you can see in the main function, we have a tail pointer which is initialized with null, and then we are calling add to empty function, and to this we are passing this data 45, and then we are calling add at beg function for adding this data, that is 34, at the beginning of the list, right? And finally, we are calling print function, and here you can see this is the print function. Here we are checking this condition: if tail is equal to null, then we should print no element in the list, else we will evaluate this piece of code which we have already seen in the previous lectures. And finally, new line must be printed after printing the list. Now let me just execute this code. You can see over here that 34 is added at the beginning of this list. So here is the add to empty function. First, a node is created with element 45, and then the node with the element 34 is added at the beginning of the list, right? Okay friends, this is it for now. Thank you for watching this presentation.